So we're going to explain today what I call the fire test for identifying plastics. The reason why is we bought this heat shrink tubing assortment. They tell us that the case that this is stored in, neatly organized in a divided PVC storage case with chart inside box for easy selection. So the plastic that this case is made from, according to that label, is PVC, polyvinyl chloride. Now, with all these different types of plastics, there is a test you can do if you don't know what kind of plastic it might be, if it's PVC or not. And this one here is actually a mystery, because I would think that a box like this would be made out of polypropylene, which is normal for this type of container and type of packaging. But hey, maybe they made this one out of PVC. Sometimes they say if you bend the plastic and it gives you a color, you know, like a white like that, you can identify it, but I've seen that happen with polypropylene as well. So we're not quite sure. So what we're going to do is a destructive test called the flame test. Similar to how you might use a flame to identify metals in a chemical solution by the color of the flame that's emitted, we're going to use the flame to burn a little bit of the plastic, and based upon the appearance of the flame and the smells emitted from the flame and the smoke emitted from the flame, we're going to identify the plastic. So let's light this up to give us a flame to work with, to light things. All right. So here we go. Now, all right, I can tell you right now already, this is not PVC. This is polypropylene. Look at that nice candle flame there. That plastic will melt. There's no smoke being emitted, visible smoke coming off the flame, and it stays lit. PVC will not stay lit once you take it away from the ignition source, because the chlorine atoms inhibit combustion. All right? But whereas polypropylene is a hydrocarbon, it's effectively solidified LPG, you know, propane, propylene gas, which is basically what we're burning right here. And it does not go out when you take the ignition source away. Look how nicely, that glassy looking that is. That is polypropylene. It is not PVC. So they have misidentified the plastic of this container by calling it PVC. Alright. So that's one way you can identify. What if we were to actually burn PVC? Let's see what that looks like. Let me find a piece of PVC and come back here. Alright, here we have a piece of PVC pipe. Right. Just a scrap. Something from some old project that I had. Let's try to burn this and see what happens to see what the flame looks like. Notice how it goes out immediately upon removing it from the torch. And it's hard to really tell, but there is a very smoky, bright color being emitted from that. And look at the end of it, how nasty and gnarly and black it is. Compare that to this, did not blacken at all. Right? PVC is very difficult to combust because of its chlorine content. And when you do get it to burn, it creates all sorts of nasty, disgusting chemistry like HCl and chlorinated products, and it's starting to stink already. I'm going to stop doing that. Even though we're venting it outside, I'm still smelling it. It's very nasty. PVC is actually a very, very nasty plastic to combust, especially in a fire situation like this, or you're at, you know, an open fire, and you can see it kind of swells out and it just gets disgusting on the end, and it smells really, really bad. Oof, yeah, it stinks. All right, now we got polyethylene, polypropylene to burn like a wax candle, like paraffin candle. PVC is a black, disgusting, stinky stuff. How about other plastics like styrofoam, polystyrene? What do they look like? Okay, so anybody who's ever like gone camping and you may have been eating off of like a styrofoam food plate, or using those plastic silverware, which is all made out of polystyrene, same plastic as this, may have tossed your garbage into the campfire and watched it combust and create that disgusting sooty black orange flame smoke. So what we're going to do is we're going to create that with this. So we're going to light our polystyrene on fire, and you'll see what I mean. This may actually be fire retardant material, but that there is the combustion of polystyrene. Yeah, I think this polystyrene has some fire retardant in it, so it doesn't really want to combust by itself. This is a building insulation material, so they add chemicals to it to try to reduce the rate at which it burns without an ignition source. But you can see there, it creates a lot of black carbon soot. And it smells disgusting. It smells like styrene, which is a very, very distinctive chemical smell. So those are the most common plastics you'll find. You'll find polypropylene, which is very similar to polyethylene. Number 2, number 4, and number 5 on the recycling symbol on the back of the package. And PVC, which is number 3. And then polystyrene, which is number 6. Let's try out a soda bottle, which would be number 1 on your recycling chart. All right, let's go find one of those. Here we have a water bottle, which is made out of plastic number 1. Does this even have a label on it for that? Actually, it does, but you can barely see it. Where is it now? I saw it. Well, I don't want to waste too much time looking for it again, but somewhere on here, there it is, barely visible. You can barely see it. Number 1, PETE, which is polyethylene terephthalate, which is polyester. So this is the same stuff that your polyester clothing is made out of, is this material here. We're going to try to burn some of this. Right, we're going to see what we get. This has almost a sweet smell to it when it burns. Okay, actually it doesn't want to stay lit either. I think most of the energy is going into melting the plastic, and that's why it doesn't want to stay lit. Because this stuff is actually pretty combustible, just like the polyethylene and polypropylene. I'm making a mess on the ground there. But this has somewhat of a sweetish, like sweet chemical smell to it when it burns. And you can see there's no black smoke. It's all just, you know, kind of either clear or... Now, if you threw this into a fire and it had enough energy to melt it and then light it, it might actually make some carbon, you know, black smoke. But right now, as we can see, it's not doing that. It's just kind of burning with a flame very similar to the plastic we had here. And of course, it's dribbling like that. It smells a little bit, yeah, kind of like candle wax, but not quite the same. I think we might be getting some of the combustion of the ring in there for the cap, but that's pretty much it. Identifying the plastic, each one of these can be identified by the unique smell and flame characteristics when it burns. So if you can't identify a plastic and you have the ability to destructively test it, this is one way to do it.